Dear students, we are in Ncert class 12 mathematics miscellaneous exercise or exercise number 12 7.12. Okay, see, until last class we have finished 30 questions. In this exercise we have got 44 questions. Still 14 questions are there. We will try to solve 7 questions in this class, or else how much time it will take and all I don't know. Let me start from question number 31 onwards. 31. Question number 31, integral 0 to pi by 2 sin 2x into tan inverse of sin x dx. Okay. See, before taking sin x is something like t or something like, let us simplify this. See what I am doing. That is equal to 0 to pi by 2. Okay. Zero to pi by 2 sin x cos x. See, sin 2x is 2 sin x cos x. 2 is constant, that is why I have taken outside. But still into tan inverse of sin x is there. Dx. Is it okay? Okay. See what I am doing now. I am taking you see cos x dx. Sin x I want to take t. Sin x is, if I take t into tan inverse of t. T into tan inverse t, cos x dx is dt. Like that it is going to become. Okay. Let me do it. But this all have to be changed. See what I am doing. Observe carefully. Sin x I am taking as t. Let sin x is equal to t. If sin x is t, cos x dx is equal to dt. Cos x dx is there. Okay, this is t, this is tan inverse of t. That is also okay. And what you require? Yes, limits. If x is equal to 0, t is equal to sin 0. Sin 0 is 0. Okay. If x is equal to pi by 2, t is equal to sin pi by 2. Sin pi by 2 is 1. Now limits have been changed from 0 to pi by 2 to 0 to 2. Okay. Proceed further. Integral to 0 to 1. Okay, 0 to 1, 2 times. Sin x I am taking as t. Tan inverse of t. Tan inverse of sin x. Cos x dx I am taking as dt. Okay. Now it has become like this. Now see, observe carefully here. Tan inverse of t is there. T is there. U into v, like which one you want to take u? You take u as this one, tan inverse t. Why? Because differentiation is very easy. Okay. Proceed further. That is equal to 2 times of tan inverse t integral t dt. Okay, v is t minus integral d by dt of tan inverse t, again integral t dt whole dt, close the bracket. Why? Because 2 times of this. Okay. Okay. Proceed further then. That is equal to 2 times of, see, integral t is t square by 2, right? Now t square by 2 into tan inverse t will be this one minus integral. See, before this what will come? 1 by 1 plus t square tan inverse x d by dx of 1 by 1 plus t square. Okay. 1 by 1 plus t square tan inverse t. Okay. And this is t square by 2 into t square by 2, outside dt will be there. Okay. See, if we send 2 inside, you see denominator 2 is going to get cancelled out. Here also denominator 2 is there. This is in multiplication, means 2 you can cancel out. That means 2 we can cancel. Okay, what it is going to become? It is going to become like this. That is equal to t square into tan inverse t minus integral t square by 1 plus t square dt. Is it okay? This I am writing as I. Okay. Observe why I am writing that this is as I or something like. Why? Because see, I want to take again I is equal to this minus I1 like this. I want to take as I1. I want to convert it. See how I am converting. Let I1 is equal to integral t square by 1 plus t square dt. This one I am taking minus, afterwards I am going to substitute. You see 1 plus 1 minus same it is going to come I1. That is okay. Another thing, how you are going to change this? You are going to change like this. Integral 1 dx. Why? Because you see 1 plus t square divided by 1 plus t square dt I have made. Minus 1 I am separating. Minus 1 integral dt by 1 plus t square. Okay? Yes. See here, how to keep this, what we can say, limits also. Limits also. If not possible, at least you keep outside. 0 to 1 like. Okay? 0 to 1 like. Here you can keep directly 0 to 1. Why? Because this is t only. Don't forget this is t only. 0 to 1, 0 to 1. Okay? See, you know very well the integral dx or integral 1 dx is, sorry, not x, t. T is t. T minus 1 by 1 plus t square tan inverse t. Okay? But limits are 0 to 1. Why? Because limits have been changed. Okay. Now you see, don't apply limit now. First of all, this I1 you substitute in I. Okay, write down. I is equal to t square tan inverse t minus this one. T minus of minus plus again tan inverse t, but limits you have to apply for entire the thing. Why? Because all are in t form. Okay. Now you need not go back to x form. T form limits you are having. Apply limits. That is equal to. You see, you cannot take anything common here. T is tan inverse t. You can take common. T square plus 1. Yes, you can take common tan inverse t. Okay, let it be. Not required. Let us proceed. That is equal to. So t square means first I am applying 1. 1 square 1 into tan inverse 1. Tan inverse 1 is pi by 4. Pi by 4 minus t is 1 plus again tan inverse 1 pi by 4. Okay. See, this is first limit minus second limit. T square 0 square. Entire thing, this is first 0 minus t minus 0 tan inverse 0. That means you need not what we can say, take that minus thing. Okay, now come back again. This is 0, you need not consider, but here you see pi by 4 plus pi by 4, pi by 2 minus 1. Write down. Pi by 2 minus 1. Have you done any mistake? Pi by 2 minus 1. How just now? 1 into pi by 4 is pi by 4 plus pi by 4. 2 pi by 4 or pi by 2 both are same. Pi by 2 minus 1. That is not required. Pi by 2 minus 1. Okay. Pi by 2 minus 1 is this thing only. Okay. Take this. We will go for next question. See question number 32. Integral 0 to pi x tan x by secant plus tan x. Secant x plus tan x dx. This is there. See, before proceeding, one final conclusion, what we are going to do, we will modify this. Why? Because by seeing itself, we came to know that all denominators are going to become cos x. You see, sine by cos, 1 by cos. Like that you have to think. Okay? Okay, let I am taking this as I. See what I am doing. 0 to pi x into sin x by cos x divided by 1 by cos x plus sin x by cos x. See, here cos x is okay, here cos x is LCM like 1 plus sin x, cos x. Both denominators are cos x, because this is in multiplication. Both denominator cos x means cos x going to cancel. Then what it is going to become? It is going to become like this. Integral 0 to pi x sin x divided by 1 plus sin x dx. Is it okay? First you see, why? Because we have converted from here to here. That means 1 we have removed, at least secant x we have removed completely, 1 we have brought. Sin x. Okay? Now see, this is okay na? I. Why? Because this I only have made like this. See what I am doing now. This I, how I am going to change. We know one property. A to b integral f of x is equal to a plus b minus x. Okay, wherever x is there only how to apply. Here it is going to happen like. Okay. Again I am making, you see, integral 0 to pi 0 plus pi minus x. That means pi minus x into sine of pi minus x divided by 1 plus sine of pi minus x dx. Is this step is correct or not? You tell me. Why? Because we have got one property. Integral a to b f of x dx is equal to a plus b minus x dx, or else integral 0 to a f of x dx is equal to a minus x dx, f of a minus x dx. That we know. Okay? Wherever x comes, there only are going to change pi minus x. 0 plus pi minus x, pi minus x, pi minus x. But we know sine of pi minus x is sine of pi minus theta. Second quadrant is positive and 180 is horizontal angle, same sign will come. That means sin x are going to come. But this is pi minus x will be like this. You see what I am writing now. Integral 0 to pi minus x into sin x divided by 1 plus sin x dx. This is also I. First of all, is it correct? Why? Because sin pi minus theta, sin theta. Okay, pi minus x will be there. See what I am doing now. I am adding both I plus I. 2i is equal to, you see what I am writing now. 2i is equal to same integral 0 to pi only. X sin x plus pi minus x sin x divided by 1 plus sin x. Well, the denominators are both same. Okay. Now, if you take sin x as common, x plus pi minus x dx. Okay. What is going to happen? You see, minus x plus x going to get cancelled. Pi is plus. This is going to become like this. You see, 0 to pi only, but pi into sin x by 1 plus sin x dx. Is it okay? Definitely okay. Pi also you can take out. Okay, pi also you can take out. You see what I am doing now? 2i is equal to this one. Again I am writing, that is 0 to pi you have taken out, sin x by 1 plus sin x dx. Okay. This is 2i, this is okay. 2i is equal to that one. You see, now I am writing like this, you see. 2i is equal to pi into I1. 2i is equal to pi into I1. Or else shall I write I is equal to pi by 2 I1. Because the 2 goes to denominator of pi. I is equal to pi by 2 I1. I1 is what? Where I1 is equal to integral 0 to pi sin x by 1 plus sin x dx. This is it okay? Okay. Now how I am converting this, you see. Technique. Plus 1 minus 1. Sin x plus 1 by 1 plus sin x. Integral dx. Like that. You change it again. Integral 0 to pi dx. Why? Because sin x plus 1 by sin x plus 1. Integral dx. 1 you need not write. Minus 1 by 1 plus sin x you have to write. Minus integral 0 to pi minus 1 dx or dx both are same. Dx by 1 plus sin x. Dx by 1 plus sin x. Okay? Now this value you know very well. See, we are doing now I1. After getting answer I1, you have to substitute in I is equal to pi by 2 into I1. Okay? That is okay. See, this will come directly x. Integral dx is x and you are going to substitute pi minus 0, pi only will come. But how to convert this? Just you think. Why? Because see, whenever in denominator any square root is there, normally we do rationalization. If you do rationalization of 1 plus x, you have to multiply with 1 minus x. 1 minus sin square x will come. Cos square x is going to come in denominator. Numerator will be 1 minus sin x. Like that you have to think. Okay. Let us proceed then. See what I am doing now. See, this value you will get like this, you see. This is I1. I1 is equal to integral x, x, this value is x 0 to pi minus, now you see what I am doing. This will be 0 to pi like this only. See what I am doing. Denominator first I am writing 1 plus sin x into 1 minus sin x. I am making rationalization. Okay. Numerator and denominator multiplying with conjugate of this. 1 plus sin x means conjugate is 1 minus sin x. 1 minus sin x. Okay. Is it okay? Okay. Now denominator is going to change 1 minus sin square x. Write down. That is equal to. But here you see you can substitute now. Limit, apply limit. Pi minus 0. Pi minus. Now also you see. Denominator I am writing, you see, 1 minus sin x by, see what I am writing, integral 0 to pi 1 minus sin x by, see, one step I am jumping, 1 minus sin square x, 1 minus sin square x is cos square x, write down, cos square x dx, is it okay? Okay? See, now, pass and note down, why? Because camera it is not appearing beyond this down. I am writing in top. Okay. See, one step I am removing this blue one, and let us see why. Because see, all data we should not remove. If that is there, then we are not going to get the answer properly. Okay. I don't think 7 we are able to do like. It is taking time. Okay, now take the red color. Okay, I1 is equal to, I am proceeding. I1 is equal to pi minus, now you see 1 minus cos square, secant square, integral 0 to pi secant square x minus sin by cos tan, and another cos will be there. This is going to become secant x tan x. Whole dx. Okay. Now you can convert this easily. Pi will be like this only. You see, integral secant square x tan x minus integral secant x tan x secant x. But apply limits 0 to pi. Okay. Okay, now you see, after getting I1, again you have to substitute in I. This you require. Red color I can remove, but yes, I have to remove. Why? Because I don't have space. Red color I am removing. Okay. Okay, after red, black. Okay. Now let us try. I think I changed color. Okay. Now proceed further. I1 is equal to pi minus. You see, tan pi will be 0. Tan 0, 0. Tan pi also 0. Tan pi will be 0. Okay. Minus. What is secant pi? Secant 180 degree. Secant pi. See, cos pi will be minus 1. Secant pi also 1 of minus 1. 1 by minus 1. Minus 1 only. Minus of minus 1 plus 1. Okay. This is upper limit. Minus lower limit. See, this is minus of minus 1. Keep in mind. Minus of minus 1. Okay. Tan 0 is 0. Okay. Minus secant 0. See, when cos 0 is 1, secant 0 also 1 by 1, 1 only. Minus 1. Close. That is equal to pi minus 0 plus 1 is 1. Minus of minus 1 is 1. 1 plus 1, 2. Pi minus 2. Okay, pi minus 2. Okay. See, pi minus 2 is the value of I1, but you require value of I. Write down again. I is equal to pi by 2 into I1. I1 value is this one, pi minus 2. Okay? You understand? Pi by 2 into pi minus 2. This is the final answer for your question number 32. Okay? Take this, we will go for 33 question. See, question number 33. 33rd question. Integral 1 to 4 modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3 dx. Okay? See, such type of question already we have done, but separately we have done. Here they have jumbled. Even you can separate, that is not a wrong. Okay? We will separate it. Why? Because that will be very easy to proceed further. See what I am doing now. One by one we have to see, or else directly also we can see. We see here, limit is from 1 to 4. That means, see, 1 to 4, this is all positive only. 0 or positive, greater than. Okay, see what I am writing. Modulus of x minus 1, or else I am writing like this. X minus 1 is greater than or equal to 0 from x belongs to 1 to 4. Okay? If you apply 1, 0, if you apply more than 1, 4, automatically this is greater than 0. Equal to 0 or greater than 0. That is one thing. Second thing I am writing, you see. X minus 2 is, you see here, 1 to 2 it is less than 0. Don't forget. Is less than or equal to 0 from x belongs to 1 to 2. Okay, 1 to 2. That means you have to take minus then. Okay? Again I am writing. Same function is greater than or equal to 0 from x belongs to 2 to 4. 2 to 4. 2 to 4. Okay? That is the case of these two functions. Now go for this third function also. Let us go for third function. Write down x minus 3. X minus 3 is less than or equal to 0 from x belongs to 1 to 3. 1 to 3 equal to 0 or less than 0. And the same is greater than or equal to 0 from x belongs to 3 to 4. That means, you see, wherever less than or equal to 0, there you have to apply minus common. Remaining area plus you have to take. Let us now write in one go this integral. You see what I am writing. First function is all positive only. Okay, positive. Then you proceed further. Then integral 1 to 4 x minus 1 dx. Okay, or else you can keep such bracket. This is okay. But see, second function 1 to 2 negative how to take. That means see, first you take negative 1 to 2 x minus 2 dx. Next plus. But this plus is where? From 2 to 4. See, 1 to 4, 1 to 4, 1 to 2, 2 to 4. Like that it has to match it. Plus you have written here minus, but plus next x minus 2 dx. Okay. Again minus you keep. Why? Because x minus 3 is minus is there. Less than. Integral 1 to 3 x minus 3 dx. Again 3 to 4 plus integral 3 to 4 x minus 3 dx. You see how many integrals now it has become? Earlier they have been only 3, but now it has become 1, 2, 3, 4, 5. 5 integrals this have become. This is called concept. Okay. Let us proceed. Now it is easy to perform this integration. Okay. X square by 2 minus x. Apply limit from 1 to 4. Okay. Minus x square by 2 minus 2x. Minus 2x. Integral 2 is x. 2x. Okay. But limits are 1 to 2. Again plus. Same will come, but integrals are going to change. Limits are going to change. Minus 2x. And this is from 2 to 4. Okay. Yes. Minus integral x square by 2. Sorry, this is x square by 2. X square by 2. X square by 2. Here x square we have not written. X square by 2 minus 3 x. X square by 2 minus 3x. But 1 to 3 plus. You see, this is minus, this is plus. Again x square by 2 minus 3. X square by 2 minus 3x. But now these limits are from 3 to 4. Okay. Proceed further then. Proceed further. See, I am applying limit. Both limits we will apply. 4 means 4 square 16 by 2 8 minus 4 minus 1 square 1 by 2 minus 1. Okay. You can keep directly. Why you all are separate, like you can think. Okay. Now you see. I think we will keep like this. Okay. Okay. 2 square 4 by 2 2 minus 2 into 2 4. Okay. This is upper limit minus lower limit. 1 square 1 by 2 minus 1 into 2 2 lower limit plus 16 by 2 8 minus 8 4 into 2 8. Okay. Upper limit is 0. Okay. 4 square 16 by 2 8 minus 2 into 4 8. 8 minus 8 is 0. Okay. Lower limit you see 2 square 4 by 2 2 minus 2 into 2 4 minus this one. 3 square 9 by 2 minus 3 into 3 9 minus lower limit. 1 square by 2 1 by 2 minus 1 into 3 3. Okay. See, we could able to write this 5 only. 1 2 3 4 only. Again fifth one also have to write. I am writing here. You see, plus you keep. Write down. 4 square 16 by 2 8 minus 4 into 3 12 minus lower limit. 3 square 9 by 2 plus 9 by 2 minus 3 into 3 9 close. Okay. Now proceed. What will be the answer? And you see, one go we will write answer. This one 1, 2, 3, 4, 5 like. Okay. 8 minus 4 is 4. 1 by 2 minus 1 is minus 1 by 2. Minus of minus 1 by 2 plus 1 by 2. That means 4 plus 1 by 2. Write down. 4 plus 1 by 2. You keep on parenthesis. Minus this one. 2 minus 4 minus 2. 1 by 2 minus 2. You see, 1 minus 4 minus 3 by 2. Minus of minus 3 by 2 plus 3 by 2. Plus 3 by 2 minus 2. Plus 3 by 2 minus 2. Okay. This is over. Second one. Plus 8 minus 8 is 0. See, 2 minus 4 is minus 2. Minus of minus 2 is plus 2. Only plus 2 will come here. Plus 2 minus. See, 9 by 2 minus 9 is minus 9 by 2. Minus 9 by 2. Okay. 1 by 2 minus 3. 1 minus 6. Minus 5 by 2. Minus of minus 5 by 2 plus 5 by 2. Plus 5 by 2 minus 9 by 2. Plus 5 by 2 minus 9 by 2. Okay. Keep this bracket. Is it okay? Plus 5 by 2. 9 by 2 minus 9 is minus 9 by 2. Minus 9 by 2. Okay. But that is, see, 1 minus 6 minus 5 by 2. Yes, sir. Minus of minus 5 plus 5 by 2. Okay. Outside minus is there. What about this? 8 minus 12 is minus 4. Minus 9 by 2 plus 9 by 2 plus 9 by 2 minus 4 plus 9 by 2 minus 4. Okay. Let me see whether space is there or not. See what I am doing? I am removing this one. Okay. We don't have space for camera. Okay. See, 4 plus 1 by 2, 8 plus 1, 9 by 2. Minus, see, 3 minus 4, 3 minus 4, minus 1, minus 1 by 2. Minus of minus 1 by 2 plus 1 by 2. Plus 2. Minus. See, 2 is LCM. 5 minus 9 is minus 4. Minus 4 by 2 means minus 2. Minus of minus 2 plus 2. Plus 9 minus 8. 1 by 2. Okay? Okay. That is equal to. You see here, if you take LCM as 2, here 9 plus 1 plus 2, 2 times 4 plus 2, 2 times 4 plus 1. Okay, see, 10, 14, 18, 19, 19 by 2. 19 by 2 will be your answer. Okay, textbook answer. Take this, we will go for next question. Okay. Question number 34. Prove integral 1 to 3 dx by x square into x plus 1 is equal to 2 by 3 plus log of 2 by 3. Okay. This is the question. We have to prove this RHS, LHS you have to take and proceed further. Okay. See, this is definite integral. Finally, answer should come this one. Now, how to come this answer and all? I am taking, you see, LHS is equal to, LHS implies I am taking not is equal to 1 by x square into x plus 1 is equal to, see, partial fraction you have to do. Okay, partial fraction. A by x plus b by x square plus c by x plus 1. Is it okay? First you see, whenever some square comes means 2 times you have to write a by ordinary and a b by x square or something square like. This is ordinary, c by x plus 1. Okay. See, what is LCM here? LCM is this one, x square into x plus 1, x square into x plus 1. Okay. See, a is having 1x means you have to take another x into x plus 1. B is having x square means you have to take multiplication only with x plus 1. C is having x plus 1 means you have to take only with x square. Like that you have to do. Okay. LCM is x square into x plus 1 only. Not x into x square into x plus 1. What about numerator? Numerator is 1. You have to equate it to numerator 1. Let us proceed then. See, a into 1 is equal to a into 1x is there. Okay. X into x plus 1. X square plus x. Directly I have written. Okay. X into x plus 1. X square plus 1. Okay. Plus b into x square is already having x plus 1. That's all. Plus c into x plus 1 we are having only x square. Then you write directly x square, c x square. Okay. See, already one side we have made 1 equivalent to 1. Now you need, okay, let us expand this. You see what I am writing? 1 is equal to ax square plus ax plus bx plus b plus cx square. Okay, that will be your expansion. Okay. Now separate it, x square terms, a plus c, ax square, cx square. Okay, and also x terms, a plus b is equal to 1. Okay. See, here 1 means only constant, b is 1. B equal to 1. 1 value already you have got, like you think. What about these x square terms, x terms are there? No, not there. That means a plus b and a plus c are zeros. Write down. A plus b and a plus c are zeros. But one value you have got. B is 1 means a is minus 1. That's all. Write down. A is equal to minus 1. Is there anything to do? No. B is 1 and a plus b is 0 means a is equal to minus b. Minus 1. Okay. When a is minus 1, a plus c is 0 means c will be 1. That's all. C is equal to 1. Write down. C is equal to 1. Whenever c is equal to 1 and a is minus 1, then only it is going to become a plus c is equal to 0. Like, okay. Now you proceed further than this, what we can say, partial fraction. A is minus 1. Write down. Minus 1 means, see how I am writing. Now see, I is equal to integral 1 to 3 minus dx by x. Okay, b is plus only, plus 1. That means you take plus integral 1 to 3 dx by x square. Why? Because 1 by x square. Okay, that is also okay. Now go for c. C is how much? C is also 1. Plus integral 1 to 3. But see, 1 means here you have to write as x plus 1. Don't forget. Okay. See here, if you are able to do at one go, you do, or else you take I1, I2, I3 like and make it separate. Why? Because you should not get any wrong answer. Here you can take t, x plus 1 as t, dx also dt, but limits are going to change. That you have to observe. Or else how you are going to take x plus 1 directly if you want to? Just log of x plus 1, that's all. You can take log of x plus 1. See, when x is linear, then you can take like that. Okay? Okay. Let us proceed. That is equal to, see, limits are okay, all. Finally you can apply limit. But this is minus log x. Write down. Minus log x. Why? Because 1 by x is log x integral. Minus is there. Minus log x. Okay. Again this you see, x to the power of minus 2. X to the power of minus 2. Minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1 means minus 1. Denominator also minus 1. That means this minus is going to become minus 1 by x. Minus 1 by x. Is it okay? Okay? X to the power of minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1 is x power minus 1 divided by minus 1. This minus 1 you take outside, minus 1 by x, that's all. Okay, come here then. Plus only you keep log of x plus 1. Modulus you keep. Why? Because here also modulus. See, x plus 1 you take in brain as x. 1 by x, log of x plus 1. Okay, now you see, you apply all the limits. 1 to 3 you have to apply limit. 1 to 3. Okay, now proceed further then. Application of limits. Okay, apply limits. That is equal to, you see, first upper limit. Minus log 3. Minus log 3. Okay, minus 1 by 3. Minus 1 by 3. Plus log 4. Why? Because x is 3 means 3 plus 1, 4. Plus log 4. Okay, close. One parenthesis. Minus lower limit. Lower limit is 1. Minus log 1, 0. Log 1 is 0. Minus 0 or plus 0, all are okay. Okay, this is 0. 1 is applied. Minus 1 by 1, 1. Plus log 2. Why? Because x is 1 means 1 plus 1, 2. Plus log 2. Log 2. Close. Okay. You see, here itself you see log of 4 divided by 3 you can make. Why? Because this is minus, this is plus. Okay. That is equal to log 4 by 3 plus minus divided by log 4 by 3 minus 1 by 3 minus log 2 plus 1. Shall I write? Why? Because minus is there outside. Minus of minus plus 1 minus log 2. Plus 1 minus log 2 means 2 by 1 is there, like you think. Okay? Why? Because for calculation purpose I have written like that. Okay. Now come back. See, 1 minus 1 by 3 minus 1 plus 3, 2 by 3. Okay. Now see, log of, see, this is plus, this is minus. See how I am writing? Plus log 4 by 3 divided by 2 by 1. That means r 1 by 2 also I can write. Okay? See, 2 times goes. That means finally what is the answer? 2 by 3 plus log of 2 by 3. This is your answer. That is equal to RHS, hence proved, like you write and close this question. Okay, see, question number 35. This is also how to prove. Prove 0 to 1 x into e power x dx is equal to 1. 1 we have to prove, but we will take LHS. Okay, see how I am doing. How can you do this? Integration by parts. You take e power x as u, or else you take e power x as v. Okay, v you take. See how I am doing. Prove. I am writing here. Okay. Okay. You see what I am doing. E power x I am taking as v. That means u is x. X integral e power x dx minus integral d by dx of x integral e power x dx again whole dx, but you keep one bracket. Why? Because limits also you have to apply na 0 to 1. Is it okay? First you see. Okay. Proceed further then. See, e power x integral means e power x only, x e power x. Write down. That is equal to x into e power x minus integral. See, d by dx of x is 1. E power x integral is e power x. E power x dx. Okay. Again you keep this limits 0 to 1. That is equal to again x into e power x minus integral e power x is e power x. That's all. 0 to 1. Okay. I think better we take inside e power x as common. E power x if I take common x minus 1, but you keep this 0 to 1. Okay. Is it okay? E power x into x minus e power x. Okay. Yes, okay. Apply limits now. That is equal to 1. If you apply e power 1 is e power 1 is e power 1 into 1 minus 1. 1 minus 1 is 0. Okay. Upper limit is going to become 0. Okay. Now minus lower limit. E power 0 is 1. 1 minus 1 into 0. Okay. E power 0 is 1 into 0 minus 1. 0 minus 1. Okay. See, this is 0. 0 minus 1 into minus 1. Minus 1. Minus of minus 1 plus 1. That is equal to 1. Is this the answer? Yes. RHS. Take this, we will go for 36th question. 36th question, if you observe, minus 1 to 1 integral x to the power of 17 into cos to the power of 4x dx is equal to 0. You have to prove. You have to take LHS and prove. See here, if you observe carefully, limits are minus a to plus a. Why? Because both are same. 1, 1, but here it is minus, that is plus. We have got one formula. What is that formula? I am writing once again here. You see, integral minus a to plus a f of x dx is equal to f of x dx is equal to 0 if f of minus x is equal to minus f of x. Okay? Why? Because it looks like, see, 0 if you want to prove means f of minus x should become minus f of x. Then we can prove. That is a simple way of doing this question. Okay. See, what is f of x? This only you write down f of x is equal to x to the power of 17 into cos of x. Then what about f of minus x? Minus x whole to the power of 17 into cos of minus x whole to the power of 4. That is equal to minus x whole to the power of 17 means this is odd number. Minus x to the power of 17 will come. Cos of minus x is cos x. Cos x to the power of 4. That is equal to minus f of x. Minus f of x. Is it okay? Yes. By above. This also you have to write. Okay. By above I is equal to 0. Okay. Integral. Or else you write this equal to 0 like you write. Okay. Let us go for 37th question. Question number 37. Integral 0 to pi by 2 sine cube x dx is equal to 2 by 3. You have to prove. You have to prove. First modify this LHS. See how I am writing. Sine cube x I am taking as sine square x into sine x. Write down. See LHS I am writing. Integral 0 to pi by 2 sine square x into sine x dx. Is it okay? Sine cube x is equal to sine square x into sine x dx. See, sine square x again you change to 1 minus cos square x. Write down. Integral 0 to pi by 2 1 minus cos square x into sine x dx. Is it okay? Sine square x I have changed it. Totally it is still sine cube x only. Okay. Now take cos x as t. Cos x is equal to t means dy dx cos x minus sin x dx is equal to dt. But here sin x dx is there. Then you send this minus this side. Sin x dx is equal to minus dt. That is one thing. Sin x dx you can write minus dt. Minus you can take out and write t here. dt. Okay. That is one thing. Another thing. 1 minus cos square x means 1 minus t square you are going to write. That is another thing. But what about limits? Limits also have to change. Let us go for limits also. See, if x is equal to 0, t is equal to cos 0, 1. Okay, cos 0, 1. If x is equal to pi by 2, t is equal to cos pi by 2. Cos pi by 2 is 0. That means see, 1 to 0 it is going. Limit. Okay. 1 to 0. reversing. Actually 0 to 1 it has to go. Okay, let us see. Now integral 1 to 0 1 minus t square sin x dx is minus dt minus dt. Is it okay? See here having two options. You remove minus and change intervals from 0 to 1. That is one thing. Or else you keep this 1 to 0 like that only, send minus inside. T square minus 1 it is going to become. Both are correct. Write down. That is equal to integral 0 to 1 I am making 1 minus t square dt. Okay. See, I am changed the sign and changed the limits. Okay. Now proceed further. Because see, 1 means t integral minus t cube by 3. 0 to 1. Okay. Proceed. That is equal to, see, 1 if you apply 1 minus 1 by 3 upper limit. Lower limit is 0, that's all. Why? Because see, 0 minus 0, that's all. 0. That is equal to 1 minus 1 by 3 means 3 minus 1, 2 by 3. Is it the answer? Okay? Okay. Now, at least good thing that we have done 7 questions in this class. Still 7 more questions are there. We will try to finish this exercise in the next class. Okay? Thank you very much.